In this presentation, we're going to attempt to answer what has become a very, very popular question in the last few years. What is this cloud that everyone is talking about and using, and why is it such a big deal? But before we jump to present day, let's actually hop in a time machine and go back 100 years ago, before the invention of the electric grid. A lot of individuals draw parallels between the electric grid and the innovation that it sparked, and cloud computing and the innovation that it is sparking currently. Now, 100 years ago, if I wanted to build widgets or power machines in my factory, I needed to build my own electric power station. If we zoom in here, we see a picture of a dynamo from this era. And to give you a sense of scale, this is a person over here on the lower left. Now, these dynamos were incredibly expensive to both create and maintain. Their parts came from a limited number of suppliers, and those suppliers could pretty much charge whatever they wanted to both build and maintain that power station. It doesn't take a huge leap of the imagination to draw parallels between this dynamo and your data center. The computing resources that you consume in your data center come from a limited number of suppliers, are very costly to build and maintain, and there's always a chance that your system administrators could put things together the wrong way and break everything. In his book, The Big Switch, Nick Carr called out exactly this relationship. He says that cloud computing today is what the electric grid was 100 years ago. And anyone who wants to belittle cloud computing should really take a close look at how the electric grid changed the face of the world. When companies could start plugging into electric power to drive things like blenders, TVs, mobile devices, so on and so forth, the world changed overnight. And it sparked 100 years of innovation, the likes of which the world has never seen. A lot of folks think that cloud computing is going to change the face of the planet the same way, when we can plug into computing resources the same way that we plug into a socket in our wall. Now let's jump back to present day and actually define the cloud. I've looked high and low, but I've never found a definition that really suits me. And though it may be arrogant, I've come up with my own. I think the cloud is really using virtualization and automation to provide users with self-service computing products that provide infinite scale at low cost. That's a really long sentence with a lot of moving parts. But if we break it down into just two pieces, the cloud is really virtualization and automation. Let's take a second and zoom in on each of these. Virtual just means not physical. So CPU, disk, RAM, and network cards are virtualized so that they can be used by many virtual computers on that machine. Let's zoom in over here on the left and take a look at exactly what we're talking about. Down here on the very bottom, we have an actual physical machine. It has a limited number of CPUs, memory, network cards, and disk. When we talk about virtualization, what we're actually doing is plugging in this hypervisor here in the middle so that we can chop this CPU, RAM, and other resources into individual small little pieces that many consumers can get a hold of. Here we're saying that we created 3 VMs, or virtual machines, on top of this one single physical machine. To each of the users who are using these VMs, these appear as physical machines. I can log into this server, I see a smaller subset of those resources, and I have access directly to each of these resources. This is what virtualization is. Software can also be virtualized so that I don't need to have my own copy of it, and many users can share it. Virtual hardware and software is incredibly easy to spin up and take down, much, much easier than physical. A lot of folks are going to take a look at this and say, hold on, we've been virtualizing for a long, long time. What is all the hype? Why is this such a big deal? Well, a lot of things have changed recently. Hardware virtualization just started becoming possible in the late 1990s. The broadband and mobile space have been driving what we call web scale, where not only do we have maybe hundreds or thousands of people accessing our services at the same time, we may have hundreds of thousands of people. The hardware speeds and capacity have only recently changed to allow this. Companies like Amazon and Rackspace Cloud just started offering their services recently. There's also been this whole SaaS, or software as a service crowd, with companies like Salesforce and Google Apps coming out of nowhere and really upsetting the marketplace. You also cannot underestimate the economy. These days, folks are trying to do a lot more with a lot less, and the cloud enables that. On the automation side, automation gives us self-service and the illusion of near infinite scale, where not only can I spin up a single server, but I can spin up 1,000 servers in that same amount of time. Automation also gives us access to utility-based pricing and service. If we draw a parallel here, I can go through every room in my house and turn on all the lights if I'm having a big party, or turn on a light in a single room if I'm reading a book. In the cloud space, I can go on and turn on 100 servers when I'm really getting hit hard, and take that capacity down to a single server when I'm not. To take a look at this self-service kiosk model, let's zoom in on Amazon's console. Here you can see that I can spin up anything from servers to DNS to databases and storage and so on, just in a couple mouse clicks. No longer do I need to go in and procure a server, wait for that server to arrive, set the server up, and then install it in a rack. I can get access to the same end product in just a few mouse clicks. Any discussion of what the cloud is has to include the three different cloud types: public, private, and hybrid. Public is what services like Amazon offer. Low-cost, leased virtual servers. It gives us the illusion of near infinite scale and gives us access to that utility-based pricing we were just talking about. This is public cloud. Private cloud is where I grab hardware, I pull it in-house, I set it up, and I set up my own cloud for my own internal users. Now, even though they can spin up servers on demand, I do have a limited scale, and I no longer have that infinite scale that we were talking about. Those servers are going to come with a fixed monthly cost. I'm going to have to purchase bandwidth, I'm going to have to cool them, and I'm going to have to replace parts when they break. On the flip side, I get total control with the private cloud. With a hybrid cloud, I leverage both public cloud resources, perhaps to burst capacity, and I'm able to still leverage my internal fixed cost and total control private cloud. If we look at a Venn diagram over here on the right, you can see that we have public cloud and private cloud. Hybrid kind of sits in the middle between the two. We also have a concept of a cloud pyramid, where we have foundational services on the bottom and more higher level esoteric services on the top. These are typically grouped into infrastructure as a service, or IaaS, on the bottom, platform as a service, or PaaS, in the middle, and software as a service, or SaaS, at the top. In this course, we're going to look exclusively at infrastructure as a service, or IaaS. This is essentially raw computing power, or raw computing services. Things like databases, queues, email servers, and raw servers themselves. Amazon's products, such as EC2, Rackspace Cloud, GoGrid, Joyent, and others, are companies who play heavily in the infrastructure as a service space. Amazon themselves is arguably the 800-pound gorilla in this space. Amazon groups about 30 independent services into what's known as Amazon Web Services. These are many different computing services that are subgrouped into compute, storage, networking, and so on. Probably one of their more popular services is Elastic Compute Cloud, or EC2. These are those virtual servers we just discussed, starting at about $16 a month. All of their services are on demand with self-service startup and shutdown, and many of these services also feature something called auto-scaling, which automatically let those servers and services breathe up to a higher capacity when a higher demand comes in. EC2 themselves also include hourly snapshots, so we have point-in-time rollbacks of what our server looked like at any given time. And it also makes very, very cool things like HA, or high availability, and high volume extremely simple to use, in some cases as simple as a checkbox. If we look at how many smaller businesses deploy their services, we typically see something like this. It's cost prohibitive to buy a whole bunch of physical machines, so they have a single machine serving as their everything. It's their web server, their database, perhaps their email server, their code repository, and everything else. Each of these independent software packages have specialized security or speed needs. But because they're all housed in one single server, we can't optimize any of these layers. Ideally, we'd like to see something like this for a web application, where we have not only independent rails of services. For example, here's a left rail and a right rail. We also have tiers. We have a load balancer in one tier, a web server, an application server in another tier, and a database in a third tier. This enables high availability, meaning that we could lose one entire rail or one independent machine and still be able to serve our traffic. And it also enables scalability. For example, if our web server or application server started getting overloaded, we could scale up more servers at this level independently of our load balancer and our database. Again, the reason that a lot of businesses don't do this is because it's cost prohibitive. The cost in the physical world to purchase these servers would run us at least $25,000. The cost in the cloud is a pay-as-you-go at about $150 a month. Hopefully that quick tour of these various areas give you a good overall definition of what the cloud is. Now we can dig deeper in the other presentations.